The nature of consciousness has perplexed humanity for centuries, inspiring inquiries across philosophy, neuroscience, and physics. Some propose that understanding consciousness requires looking beyond traditional models of brain activity and exploring the quantum realm, where reality itself behaves in ways that defy classical logic. The conventional scientific view links consciousness to neuronal activity within the brain. Neurons communicate through synapses using electrical impulses and chemical signals, forming intricate networks responsible for thought, memory, and perception. This mechanistic model assumes that consciousness arises from complex computations performed by neural circuits. However, some researchers argue that this perspective may be insufficient to explain consciousness's subjective, qualitative nature. They suggest that the mysterious process through which conscious awareness emerges might involve quantum mechanics, specifically the transition from quantum states to classical reality. Quantum mechanics governing the behavior of particles at the smallest scales operates with rules that seem alien to everyday experience. Particles can exist in multiple states simultaneously, a phenomenon known as superposition, and become entangled across vast distances. These features challenge deterministic views of reality. One theory proposes that consciousness could be linked to quantum processes within the brain, potentially offering a non-computational element. The central idea is that quantum coherence, when particles remain interconnected in a unified state, might persist within specific brain structures, enabling consciousness to emerge. A notable hypothesis focuses on microtubules, tiny structures within neurons that support cellular functions. Some suggest that microtubules might sustain quantum coherence long enough for meaningful quantum effects to influence brain activity. In this view, consciousness arises from orchestrated reductions of quantum states within these microtubules. The proposed mechanism involves quantum state reduction, where a quantum system collapses from multiple possible states into one defined state, a process some consider analogous to making a conscious decision. If this reduction is guided by a form of global coherence involving many neurons, it could form the basis of conscious experience. Critics point out significant challenges. The brain's warm, wet environment is typically seen as hostile to sustaining quantum coherence, as interactions with the environment cause decoherence, disrupting quantum effects. For quantum theories of consciousness to hold, microtubules or other brain structures would need to overcome this limitation. Supporters of the quantum approach argue that new discoveries in quantum biology, where quantum effects have been observed in processes like photosynthesis and bird navigation, suggest that quantum phenomena might occur in biological systems despite environmental challenges. An alternative view holds that consciousness might influence quantum systems rather than the reverse. This interpretation suggests that consciousness could be a fundamental aspect of reality, collapsing quantum possibilities into definite outcomes. This idea parallels interpretations of quantum mechanics, where an observer's awareness is essential for defining reality. While speculative, these theories raise profound questions about the nature of mind, reality, and existence. If consciousness is connected to quantum processes, it could imply that awareness plays a direct role in shaping the universe at its most fundamental level. The philosophical implications are vast. If quantum processes underpin consciousness, then subjective experience might be embedded in the universe's fabric, challenging materialist views that regard consciousness as an epiphenomenon of neural activity. It also raises the possibility that consciousness extends beyond the human brain, existing wherever quantum coherence might arise. Advancing this field requires collaboration between physicists, neuroscientists, and philosophers. Developing precise models that integrate quantum physics with cognitive science could reshape humanity's understanding of mind and reality. The search for consciousness's origins continues to inspire scientific exploration and philosophical reflection. Whether through quantum theories or future discoveries in neuroscience, the quest to unravel the mystery of consciousness remains one of the most profound challenges in human understanding. Exploring consciousness through a quantum lens also invites reconsideration of long-standing philosophical debates about free will and personal identity. If conscious decisions are linked to quantum state reductions, this process could provide a physical basis for free will, countering deterministic interpretations of the brain as a purely mechanistic system. Some theorists suggest that quantum entanglement could explain interconnectedness in conscious experience. If conscious minds are linked through quantum processes, it could offer a scientific framework for phenomena like empathy or collective awareness, often considered metaphysical. The possibility of quantum-driven consciousness also touches on existential questions about life after death. If consciousness is tied to quantum information that persists beyond the physical brain, it could suggest forms of existence that transcend biological life, challenging conventional views on mortality. Research into artificial intelligence, AI, further complicates the exploration of consciousness. If consciousness depends on quantum processes unique to living brains, creating truly conscious AI may be impossible. Conversely, if quantum principles can be engineered into artificial systems, it raises ethical questions about AI rights and moral responsibility. Interdisciplinary collaborations continue to explore these frontiers. Physicists develop theoretical models of quantum consciousness, while neuroscientists seek empirical evidence through advanced brain imaging technologies. Philosophers refine conceptual frameworks that connect scientific findings with questions of meaning, purpose, and self-awareness. The quest to understand consciousness extends beyond intellectual curiosity. It influences technology, medicine, and ethics. Breakthroughs in this field could revolutionize mental health treatment, offering new ways to address conditions like depression, anxiety, and neurodegenerative disorders. As humanity seeks deeper understanding, the integration of quantum theory and consciousness research challenges long-held assumptions about reality. The merging of scientific insight and philosophical inquiry continues to push the boundaries of what is known, leaving open a vast horizon for discovery and wonder.